In this video, we'll be finding the determinant of matrices. So let's start with the 2 by 2 matrix. So this only applies to 2 by 2. So if we have a matrix 2 by 2, which is A, B, C, D, the determinant of any 2 by 2 matrix is A times D minus B times C. So now let's look at some examples to see this formula. So here we have 4 matrices. So let's start with A. So A is 3, 2, 3, 1, 5, and as we know from the formula is this term, let me highlight this times 3 times 5 minus 2 times 3, 2 times 1, sorry. So let's just do that, it's very simple. So 3 times 5 minus 2 times 1, and that will give us 15 minus 2, 13, and the determinant of matrix A is 13. Let's move on to matrix B. You can try it yourself. So it will be 3 times 0 minus, don't forget the minus, some students make that mistake, 6 times 1, which will give us minus 6. So determinant can be negative, by the way, so determinant is minus 6. Moving on to C here, it is 0 times 5 minus 1 times 0. So 0 times 5 minus 1 times 0, which is 0. So here determinant is 0. And for the last one, D is a 0 matrix, and the determinant of any 0 matrix is obviously 0. And yeah, so now let's move on to 3 times 3 matrix. So this is a bit more trickier, and I'll show you one method which is very easy, and it's easier compared to the other method. So here we have a 3 by 3 matrix, and the way to find the determinant for this is to choose any row or column, and it's best to choose a row or column with the most zeros, as you'll see later why this is helpful. So let's choose the first row, which is 3, 1, 0, and let's start with this. So first thing we'll do is we'll write 3 and then open brackets, and now what we have to do is we have to cross this like this and then just like this. So what is left? Negative 3, 5, 1, 6. So we'll write the matrix here, minus 3, 5, 1, 6. And now remember this sign. Let me just remove this, it's making it more confusing. So as we can see, the next sign is negative, so we have to do minus 1. And now again we have to do, one second, where's my eraser? Yeah, now what we have to do is we have to remove this line here. So what is left now? 2, 5, 0, 6. So that's the matrix we have to do. 2, 5, 0, 6. And again, next one, the sign is plus, so we just have to do, and yeah, as you can see, it's 0. So this entire thing will be 0, since if we take this row out here, one second, I'll just show you. Now we have to take this column out. So what is left? 2, negative 3, 0, 1, and this entire thing will be 0, since you're timesing by 0. That's why we choose the row or column with the most zeros. So now if you simplify this answer, it will be 3 times negative 3 times 6 minus 5 minus 1, open brackets, 12 minus, 5 times 0, and simplified it will be 3 into negative, one second, yeah, negative 18 minus 5 minus 1 minus 12, and then more simplified it will be, let me just get the final answer on my calculator. The final answer is negative 81. So this is the way to do this. And if we choose, let's say, we chose the first row here. So if we choose the second row, let's do the second row now. So if we choose second row and we repeat the same steps, we'll get 2. And again, don't forget this crossing. So if we chose the second row and it's 2 first, so this column and this row will be out, and the matrix left inside will be 1 0 1 6. And don't see, I made this mistake. I forgot the minus here, since we have to always remember this. So this is a very crucial rule we have to remember. Okay, so don't forget the minus. So it's minus first, minus 2 into this matrix, and then next will be plus, and it will be minus since it's minus 3 here. So minus 3 open brackets, and we take this out now. So let me just show you that. So the column and the row of that digit, okay? So this here, so what is left? It's 3 0 0 6, and then last is minus again, don't forget this rule, 5, and then we can just do that, 3 1 0 6 0 1 3 1 0 1, yeah. And again, simplify this, minus 2 into 6 because of 0, minus 3 into 18, minus 5 into 3, and final answer. Again, you will get the same answer as before. So it does not matter which row or column you choose, but you have to remember this rule here, and again, don't make any silly mistakes. And yeah, so here we have a matrix B with this matrix here, and you can pause the video and try finding the matrix yourself. So I'll choose the first row, which is this row here, and you repeat the same steps here. So we'll get 1, and don't again forget these signs. It will be 1 into 5 1 1 2 minus 2, and then open this matrix again, which will be 3 1 minus 2. If it's very hard to see the matrix, you can always draw the crossing line and column, cross the row and column. And then finally, again, don't forget the sign. There's minus here and it's minus 1, so it will change into 1 plus 1 open brackets, not open brackets, the matrix, 3 5. Okay, I made a mistake here. It is plus here, sorry. Yeah, this sign is plus here, sign is minus here. I was looking at the second column for second row for some reason. So minus 2 1, and you can simplify this answer now. So it will be 10 minus 1 minus 2 into 6 minus plus 2. Don't forget the 3 times 2 minus 2 times 1. So the minus will become plus, and then here minus 3 plus 10, and simplified it will give you the final answer of minus 20. So here we have a 4 by 4 matrix, and we can use the same method as the 3 by 3. So choose any row or column, but again I'm giving the tip that you have to choose a row or column with the most zeros, else it will simplify over some steps a lot. So take a moment, pause the video, and try to find the row or column with the most zeros. And the column I'm going to choose is of course the second column, as it has 3 zeros, and it will be only one step here. So here we will get 2, only 2, since all the other are zeros. So 2, and the thing which will cancel out, we can just do that also just to simplify more. So this row will cancel out and this column, and we are left with the 3 by 3 actually. So we have to do one more step actually. So here 3 0 1 4 1 2 3 2 1, and then we have to simplify this even more. So again we have to choose a row or column. I'm going to choose the first row as it has 1 0, so we will get 2 into open brackets 3, and then again this column and this row will cancel out. 1 2 2 1, and then minus, this is minus and 0, so 0, and then again plus 1, and again cancel this row and this column out, so we're left with 4 1 3 2. Again you can always draw the crossing if it simplifies and helps you, and don't forget the signs. This is plus 1, and the final answer will be 2 into 3 into 1 minus 4, and then plus 1, and then open brackets 8 minus 3, and then close brackets, and the final answer will be minus 8. And one more tip I can give you is that you can, if you have a calculator and you have the matrix function, you can find the determinant by typing in the calculator, but that will only give you the final answer. So if you want to recheck your answer, because it's very common to make a silly mistake in this, especially with the signs, so you can recheck your answer with that. So here are some conditions that you have to remember. So the determinant of any triangular or diagonal matrix is the product of the diagonal itself. So let me just show you what a triangular or diagonal matrix is. So example would be, if we have, okay, this will be a diagonal matrix. I'll just show you 1 2 3 0 0 0. So a diagonal matrix is basically matrix which only has numbers on the diagonal itself. So very simple to understand. And let's take a 4 by 4, 1 1 1 1 0 0 0 0 0 0 0. Yeah, so this is what a diagonal matrix is. And for triangular, it can either be upper triangular or lower triangle. I'll show you both. So let me just build on this one actually. So this is a lower triangle. So as you can see, there is a triangular lower triangle right here, and there are no elements on the top here, and vice versa for upper triangular. If I do 1 1 1 1 2 3 and 1 here, oops, I did something wrong, I think. Yeah, here, why is there 1 here? 0 0 0. So this is a upper triangle now. So as you can see, we have a upper triangular over here, and there's only zeros on these elements. So what this both this is lower triangular and this is upper triangular. So now, and the other condition is that the determinant is 0 if one of these statements are valid, which is that if a row or column is 0, like the elements of a row or column is 0, or the other condition if the rows, any two rows or columns are equal, or they are scalar multiple, which I'll show in the example below, or they are linear computation of feature. So let's get to the examples to further understand this. So here we have a 5 by 5 matrix which we want to find the determinant, and as we can see, this is a upper triangular matrix as there are zeros below the diagonal, and so straight away we can say the determinant is equal to the product of the diagonal, which is going to be 5 times 1 times -3 times 1 times 10, which is going to give you -150. So I want you to pause the video now and use these conditions or rules to find the determinant of these three matrices. So you can pause the video now, and I'll be solving these now. So in the first matrix A, we can see that row 3 is equal to 2 times of row 1. So this is this condition, which is it is a scalar multiple. So since R3 3, which is this row, let me underline it, let me highlight it actually. Okay, I'll do that highlighting later, is equal to 2 of row 1, this row and this row. So the determinant of A is 0. So we can straight away say that determinant 0 if we find this condition. So equal to 0. And matrix B, you can again try and see. So here we have that if the column of the third column is equal to column 1 and plus column 2. So column 3 is equal to column 1 plus column 2, which is this condition, linear combination. So that's why the determinant here is also equal to 0. And as for the last one, we can see that it is upper triangular, as there are only zeros below the diagonal. So we just have to do 2 times 1 times 2 times 6 times -1, which is equal to -24. So here are some more conditions that you have to remember. So this is when the questions are asking, let's say, determine, and just I'll do some examples to explain these conditions. So here we have two matrices, which are A and B, and the order, which is if it's a 3 by 3 or 2 by 2, so it's 3 by 3 both of them, so n is 3. So here we have the first question to find 3a, determinant of 3a. So we have to use this first condition here, since k is a constant here and the k is 3 here. So let's use that. So it will be, if you take 3 outside, it becomes 3 to the power of n, and n here is 3. So 3 to the power of 3, and times the determinant, which is the diagonal here, since it's a lower triangular matrix. So it will be -5, which is equal to -135. For the second one, there's a -1 here, so we have to take the -1 outside since it's the constant, and again we have to use the first condition here, so it will be -1 to the power of 3. So -1 to the power of 3 times determinant of B, which is also the diagonal here since it's a lower upper triangular matrix. So it will be -88, and the final answer is 88. Yeah. Just 1 second, let me make this clear. Yeah, so moving on, the determinant of transpose does not change the determinant. And if you don't know what transpose means, it means, let's say if we have 1 2 3 4 5 6 7 8 9, we just flip the rows and columns. So it will become transpose of this matrix is we flip the rows and columns, so it becomes 1 2 3 4 5 6 7 8 9. So this is what transpose means. So that's clear now. So it does not change it, so the answer for this will be -5. Yeah. Okay, so for this question now, this is we just use the second condition here, which is just timesing both of them. So it will be -5 times -88, which is equal to 440. And for the last question, we actually add the matrices first individually. So it will be, the matrix will be, I'll write it here, 3 6 -4, and then -2 -6 7, and then 3 9 3 and then you just find the determinant like using the row reduction. So you can do that yourself, I won't be doing it. So here are some last effects on the determinant if we do any of these operations. So if we interchange any rows or columns, the sign of the determinant flips. So basically, let's say if determinant is 1 and we flip the row 1 with row 3. Oops, yeah, let me just change the color. Yeah, so the sign will just flip. I'll show an example all these three conditions. The second one, if we times row 1 by, let's say, 3, we would have to multiply the determinant by 3 also. And if we are adding to a scalar multiple of any row to another row, this does not change the determinant in any condition, so the determinant will stay the same. So now let's look at some examples. So here we have a 2 by 2 matrix and the determinant is 13. We have the first question: if we interchange row 1 with row 2, what will the determinant be? So if we switch the any two rows, the sign of the determinant flips. So determinant here will be negative 13. Here we have, if we multiply row 2 by 3, that will be we have to multiply the determinant with the constant we are multiplying with. So 13 times 3 will be 13 times 3 is 39. And then the last question, if we're adding negative 2 of row 1 to row 3, this does not change the determinant at all. So if you're adding any constant, not constant, any multiple of a row to another row, the determinant stays the same, so the determinant is still 13. So that's all for this video. If you have any questions, you can ask in the comment section and I'll be happy to help. So, and also you can always comment on which topic should I explain on my next video, and I'll see you next time then.